So from last time we did this problem and we didn't have opposites to begin with, so we had to make opposites. We decided to make opposites in the x term, which is why we multiplied the top equation by 3 and the bottom equation by -2. Our target number here was to make both of these a 6. One has to be positive, one has to be negative, so that we can add. 3 times 2 is positive 6. -2 times 3 is -6, so that creates the opposite, so that when we add, the x terms disappear. But when you multiply an entire equation by that number, you have to distribute it to every single term. So 3 times 2x is 6x, but then 3 times 7y is 21y, and 3 times 4 is 12. So the new equation has everything multiplied. -2 times 3x would be -6x, -2 times 5y, -10y, and then finally, don't forget the last one, -2 times -5, +10. That's like the 8th time I've said don't forget the last one. But people will still do it. Don't let that happen to you. Distribute to everything. Now we can add the 6x and the -6x goes away. We add these two together, we get 11y. We add these two together, we get +22. Solving for y, divide both sides by 11, you get y equals 2. Once you're here, it's a piece of cake to go back to one of the original problems. Just pick one, or one of the original equations. Just pick one, it doesn't matter which one. Looks like we chose the top one, so we wrote 2x plus 7 times y is 2, so we wrote 2 equals 4, and then solve for x, and you get x equals -5. So then you write your answers in ordered pair, -5, 2, and then you check your answers in your original equations to make sure that they work. -5 times 2 would be -10. 2 times 7 would be +14. Put those together and you get +4. -5 times 3 is -15. 2 times 5 is 10. Put those together and you get -5. So this is the correct ordered pair for this system of equations. No other ordered pair will work. So that's why you check. All right, let's talk our way through the second problem then. What do we do? Yeah, we don't have opposites right now, right? So what are you doing? What are you trying to do? The same number, and one is positive and one is negative. You can choose x or y. Which one do you want to choose? So it doesn't have to be x. We can pick x, though. If we pick x, what would our target number be? 15. What if we picked y? What would our target number be there? 14. All right? So either one of these you can eliminate. Just pick one and go. Which one do you want to do? All right, we're going to eliminate x then, which means we need to wind up with 15 and -15. Since I don't have room to write on the left, which is where I normally write, well, actually, let me just change colors so we don't get confused. And I'll write it on the left. I like writing this on the left. What do I need to multiply my top equation by then? Okay, -5. That will give me my -15x. So then my bottom equation must be multiplied by +3. I've taken care of that negative sign already. So now we distribute. And what do we get in the top equation? Yeah? Doesn't matter. That doesn't make any difference as long as one is positive and one is negative. -35y equals -75. All right. Bottom equation? So +6y equals -12. All right, do we have opposites in one of our variables now? Yes, that was our goal. So we can draw our line and add these two equations together. What happens to x? Goes away. What happens to y? So -29y equals, and what do we get here? What is it? -87. All right, so solve for y. Divide both sides by negative 29. Y equals what? 3 is correct. So even though those numbers were kind of ugly and negative, it's no big deal. We still get y equals 3. Now what do? Plug it into one of the original equations. Doesn't matter which one you pick. Which one do you want to pick? Which one? Just pick one. The bottom one? Fine. So we have y equals 3. So I'll write 5x plus 2 times y, which is 3, equals negative 4. And then just simplify this down. 5x plus 6 equals negative 4. So we're going to subtract 6 from both sides, and we get 5x equals negative 10. Divide both sides by 5. And we get x equals negative 2. Oh, I don't want to circle that, do I? I keep doing that. What do I want to do? Ordered pair. So my ordered pair will be negative 2, comma 3. X coordinate first, then the y coordinate. Then I put a box around it. And then I'm almost done. What do I do now? Check it. So you plug these things in to check. This is the right answer, though. We're good to go. How about the last one? That one's for you. Go ahead. For this system, you can eliminate x or y. I'm looking at this, and I'm thinking I need to create opposites, which means they have to have the same number with different signs. If I look at x, I don't have opposites, and I don't have opposite signs either. But if I look at y, I don't have opposites, but I do have opposite signs. So I'm actually going to choose to eliminate y here, because then I don't have to multiply by a negative and potentially mess that up. So I'm choosing to eliminate y, which means my target number is going to be what? 45. So in order to turn 5y into 45y, I need to do what? Multiply both sides, multiply the entire equation by 9 with my fancy butterscotch color. What do I need to multiply the bottom equation by to make opposites? Yeah, it's just 5 this time, because I already have the opposite signs, which is nice. So now I draw my arrow over, and as I look around the room, I see some of you not doing that. I highly, highly recommend that you get organized in the way that you're doing these problems, because pretty soon we're not going to be solving 2 variable systems of equations. We're going to be solving 3 variable systems of equations. And that's a lot more work, and if you're not organized, you will get lost. So draw your little arrow over and then rewrite those equations. 7 times 9 is 63, so 63x. 9 times 5y is plus 45y. Distribute the whole thing through. 9 times 2 is 18. Then 5 times 8x is 40x. Then 5 times negative 9y is negative 45y. Notice I made my opposites there. Then 5 times 17 equals what? 85. We have opposites here now, so I'm going to draw my line and add. 63x plus 40x is 103x. The y terms disappear, the equal sign comes down, and 18 plus 85 is 103. Divide both sides by 103 and I get x equals 1. So now I take that and I substitute it back into one of these 2 original equations. The top one to me looks a little bit easier, so I go 7 times 1 plus 5y equals 2. That's 7 plus 5y equals 2. Subtract the 7 from both sides. 5y equals negative 5, sorry. Divide both sides by 5 and I get y equals negative 1. And I did it again. Get that out of there. I write my ordered pair, 1 comma negative 1. Then you would check it to make sure that it's right, because only one ordered pair will work here. After we checked it, we found out that this is right. So then you move on. All right, as always, there's some special situations that we have to take care of. Solve each system. So that first one, notice that I already have opposites right here, so I'm good to go. I draw my line. Negative 3x plus 3x becomes 0. But then I have y plus negative y, which becomes oh, so there's a typo on yours. Change that to a y right there. It's not supposed to be a 5.
So you have 0y.
So that's a 0 also. Equals what? 0. So what happens is the entire equation disappears. You wind up with 0 equals 0. No. This is all, infinitely many solutions. Infinitely many solutions. Infinitely many solutions. The reason it's infinitely many solutions is because these are the exact same equation. This equation right here, if I multiply the top equation by -1, I wind up with positive 3x minus y equals positive 5. It's the exact same equation as the bottom equation. So that would mean if I graph them, they would wind up graphing the exact same line, which means that every ordered pair that is a solution for one is a solution for the other. And that's why it's infinitely many solutions. And you do have to write infinitely many solutions. Take a look at the one on the right. Do we have opposites right now? Yeah, so we're ready to add. So we do, and what do we get? I'm adding, so I get 16. Does 0 equal 16? No, it doesn't. The reason we got something weird like this is because if we were to put these equations in slope-intercept form, we'd wind up with the same slope but a different y-intercept. In other words, these two lines do not cross. They're parallel. In that case, there are no solutions. So you'll write no solution. The bottom two equations, the bottom two systems of equations do not have opposites set up already, here or here. We need to make opposites. So just pick a variable to eliminate, and we'll multiply the top equation by that number. Which variable do you want to get rid of? Doesn't make any difference. I heard x first, so I'll have to multiply the equation by -3. Draw my arrow over, and I write -12x minus 3y equals -18. My bottom equation is 12x plus 3y equals positive 18. I add these together, and what do I get? 0 equals 0, which is true. So the answer here would be infinitely many solutions. And the last one, pick a variable to eliminate. Which one do you want to get rid of? X, okay, so I got to multiply the bottom equation by what? 2. Notice I'm not multiplying top and bottom. It's not just 2, it's -2, so that I have opposites. I can just multiply one equation if I need to. Rewrite the system. We have 6x plus 4y equals 2, and then we have -6x minus 4y equals what? Positive 2. So now we add, and we get what? 0 equals 4. No solution. Music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? What is the first thing we need to do on a problem like this? It's kind of hard to set up equations if you don't know what the variables are. So we need to define some variables. How many variables are we going to have? There are 2. What is the cost? That's going to be one variable. And the one-time fee, that's going to be your other variable. So what variables do you want to use? Okay, C equals cost per lesson. And then F for the one-time fee. Normally they give you the one-time fee, but in this case they didn't. So that's why we have to figure it out, and that's why we're calling it a variable. Now the problem, if you look at this problem in the book, they give you this information right here to try to help you set this problem up. The sign right here tells you that 6 lessons cost $300. That's including the one-time fee. How do I know that it's including the one-time fee? Yeah, it says right there, prices include the one-time fee. Okay? So $300 like out the door is how we would say that. So I need to come up with some sort of expression or equation that says the stuff equals $300. I'm getting 6 lessons at some sort of amount per lesson, so 6C, and then I got to tack on that one-time fee, which we called F. That together costs $300. Then we have a second situation, 12 lessons for $480. Well, that's a system of equations right there. We have 2 variables, 2 equations, so we can solve that system of equations using the math we've been doing so far. I need opposites, right? I need opposites. Do I have opposites in either of my equations right now? Either of my variables? No, I don't. But I can make opposites very quickly if I choose to eliminate the right variable. Which variable should I eliminate? How about F? If I choose to eliminate F, all I have to do is multiply the one of these whole equations by a -1. That will change all the signs. So now I have -6 minus F equals -300 if I multiply that top equation by -1. Now I can add, and I get 6C, the F term disappears, equals 180. Divide both sides by 6 and you get C, the cost for one lesson is $30. Now I substitute back in to find out what the original fee was. So I can go back to 6 times 30 plus F equals 300, an original equation. This is 180 plus F equals 300. Subtract 180 from both sides, F equals $120. This is a story problem, so I need to answer this in terms of the problem. Each lesson is $30, and the one-time fee, or the materials, are $120. There's your answer. How much is a download? 95 cents, and the one-time fee? $5.50. If you didn't get that, you did something wrong. It's okay. What's the first thing we want to do here? Define the variables. So what did you pick? D equals the cost per download. That list says download. And then what's your other variable? F equals the cost of the fee. Yeah. So we are talking about money here, okay? Our units here are money. So we need 2 equations. First equation comes from 15 downloads for 1975. So equals 1975. That's 15 downloads. So 15D gives me cost. This is a cost right here. So I need money all the way through this equation. I have 15 things that cost me a certain amount of money. That gives me money right here. Plus what? The fee, which is more money. Money plus money equals money. Second equation comes from 40 downloads for $43.50. So 40D plus that one-time fee again equals $43.50. That's the system. Now what? Make an opposite. So which variable are we talking about here? Yeah, I don't want to deal with this one. Make this one have opposites. So I'm going to multiply the top equation by -1. Draw a little arrow over, rewrite the system. This becomes -15d minus f equals -19.75. Remember, that gets distributed to everything, not just one side. On the bottom, we still have the 40d plus f equals 43.50. Now we have opposites, so we can add. What do we get? 25d equals 23.75. And then we divide both sides by 25, and we get d equals 0.95, which is 95 cents. So it's 95 cents per download, and then we can substitute that back into one of our original equations, always an original equation. And when we do that, since I don't have room here, I won't show the work, but we wind up with f equals what? 5.50. So it's a $5.50 initial fee. So then your answer needs to be written in a way that makes sense for this problem. It's 0.95, so 95 cents per download, and one-time fee of $5.50. The wording on that is important. Make sure that you do write your answer in the context of the problem. It's important that you can do that. So that's the whole section.